Hello and welcome to another LeetCode problem. Today we're going to be doing array with elements not equal to average of neighbors. And so in this problem you're given a zero index array nums of distinct integers. You want to rearrange the elements in the array such that every element in the rearranged array is not equal to the average of its neighbors. And so that's pretty straightforward, right? So if you have elements, you want to make sure that the elements to the left and the right of it do not make it the average. So for example, like this 3, we wouldn't want to have it here because the 2 and the 4 on both sides do average out to 3. So we want to figure out how to move our numbers. And so they show for this first. And this kind of problem is done in like a bunch of other LeetCode problems, like the thing we're going to be doing. So it's going to be a good algorithm to know. It's pretty straightforward. Okay, and so now they're showing that here, as you can see, 2 is not equal to the average of 1 and 4, 4 is not equal to the average of 5 and 2, and so on. So how would we do this? Well, it's actually going to be reasonably straightforward, and I'm going to show you what we're going to do, and it's actually not super hard. So what we're going to do is we're going to first sort the numbers, right? So they are sorted in this case. Then we're simply going to do a two-pointer technique. So we're going to have a pointer here and a pointer here. And then all we're going to do is to our output, we're always going to print the smallest number and then the biggest number and then keep moving our pointers down. So let's see what that looks like. So if we have 1, 5, now we move our pointers down here. Get rid of these. 2, 4. Now we only have one thing left. And so what that does, as you can see, is if it goes like smallest, biggest, smallest, biggest, smallest, biggest, now every element is either bigger than the two elements on the side, right? Because if you think about it, this would be like small, like if this is like small, big, small, big, small, you either have an element that's surrounded by two smaller elements or you have an element that's surrounded by two bigger elements. And so in that case, we actually can't have an average. That is the number, right? The only way we could have an average that's a number is if we have a number that's on one side. So it either has to be a number and then two numbers on both of it are the same, but this is actually distinct, or one number has to be bigger and one number has to be smaller. So we're sorting it in a way where every bigger number is surrounded by two smaller numbers and every smaller number is surrounded by two bigger numbers. And this kind of format is going to be pretty common to solve like a few of these LeetCode problems where you're trying to do some similar thing like this, where you're trying to make sure the average isn't the case, or you're trying to make sure it's like some kind of like wiggle sort type of thing. I think it might be what it's called. And so this is what you would do. You would go small, big, small, or you can go big, small. It doesn't matter. But you just have an alternating sequence. And let's actually look what it's going to look like for the second example as well. And this should work for anything. So first, remember, we're going to sort. So for the second example, we're going to sort this 0, 2, 6, 7, 9. Okay. And now we are going to go small, big, and so on, right? So 0, 9. We have the next small, 2. And we have the next big, 7. And then we're guaranteed to have some small, big, whatever. And then the last element can either be smaller or bigger. It just depends on where it ends. But as you can see now, this 9 is surrounded by two smaller elements. So obviously the average of them is not going to be 9. This one's surrounded by two bigger elements, two smaller elements, and then the things on the side don't have an average because you need two elements for that. And so that's pretty much it for this problem, actually. That's all we have to do is we just have to sort it, and then we have to do the left and right pointer and move our pointers. And as you can see for this nums length, it's actually 10 to the 5th, meaning we can have an n solution or we can have an n log n solution, and this should be an n log n solution. We can't have an n squared solution, and now we don't even need to calculate these averages because we know that the way we sorted and are going to print our numbers, we're never going to have the case where the average of the number is the two numbers to the left and the right. So let's actually code that up. So it's going to be nums.sort. Now we're going to have a left and a right pointer. We're going to have our output array. Now we are going to say while left less than or equal to right. And so what we can do is if left equals right, then we can just pop the value and return. So let's do that. So that's going to be nums left, let's say. and we can break here. Okay. Otherwise, pretty straightforward. So we're going to do res.append nums left. Then we're going to res.append nums right. And then we are going to update those two values, right? So hopefully I didn't screw up any logic there. We just return the res here. That should be it, I think. Let's see here. Oh, that should be -1. Okay, nice. And it's a pretty efficient solution as well. And so let's do the space and time complexity for this one. So yeah, pretty easy once you kind of know what you're doing, but you definitely figure that out. You might really get, screwed up by like, how do I figure out the averages or what would I do? But once you kind of get what you need to be doing, it's pretty straightforward. So for the time, so we did a sort, so it's going to be n log n, where n is the length of nums. And then we just have a left and a right pointer, so that's just big O of n for that. For space, it's going to be big O of 1. We do have the output array, but that's the thing we're returning. So it's either going to be big O of 1 or big O of n, depending on if you want to count that output array or not. There might be some solution where you could do this. Yeah, there might be some solution where you could do this in place, where it might be a little bit less efficient in time, I think. But for the most part, you generally don't want to you can, depending on your constraints, but generally you don't modify your argument in place. You generally make a return argument. So I think that's efficient as it gets. Okay, so that's gonna be it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.